moved from one to the other, so you actually get double the time. But we've got Andrew speaking on biodiversity adaptation to climate change in the Mount Lofty Ranges, evidence, scenarios, synthesis and management implications. But I think from that last presentation, we're looking at that finer scale. And I'll hand it over to Andrew. Thank you.
Thank you. Thanks, everyone. Hopefully I don't go over too much of the same ground that Dan's covered, but it does relate to that same sort of assessment type process. What I'm going to cover in the presentation is just go a little bit over the background. What's the problem we're trying to address? What's the path we've gone through to try and find a solution, and where to from here? And just to provide a bit of context, the terms get bandied around. There's mitigation, there's adaptation. Mitigation is really trying to minimise our contribution to anthropogenic climate change. Adaptation is really trying to deal with the fact that we've already got a legacy of climate change that we're facing. How do we minimise the impact of that? And so really what we're focusing on, the work we've done, is very much in the adaptation space. So what we wanted to do was really try and pull together the existing information. Could we produce a bit of a synthesis to guide delivery within our region? What we found when we started getting into it, as most people are probably aware if they've delved into this, climate change has become a bit of a flavour of the past decade. The amount of literature published on this is growing by the minute. And what you find is there's all sorts of different aspects people have tried to tackle. There's the different scenarios, the different projections, the uncertainties. On top of that, people have looked at the actual drivers. They've also looked at responsive systems. They've come up with focus on different taxonomic groups, and they've come up with different results and different implications. So as a result of all of that, we really went, well, how do we pull synthesis out of this to guide what we actually do delivery-wise within our region? And the path we went down to do that was actually a systematic review, which is something we've kind of borrowed out of the medical profession, where they try and synthesise a whole bunch of work that's done to see whether there's some emerging patterns when you actually evaluate and review it. So the process we've gone through is to try and assemble that data, assess what it means, bring it together, then look at the likely scenarios for change and the implications, and see whether we can determine those broad response strategies, which Dan was talking about, but also getting down to the more pointy end of what we would actually do on the ground. In terms of the approaches being used, there's probably three main sort of scales of focus, I suppose. There's these sort of regional type assessments where people are looking at things like climate velocity. So if climate is moving, how far would I have to move to stay in the same climate I'm in now? What's the rate of change? And that's essentially like having a torch with a dim light that casts a fairly broad picture. So you get a broad shape of some of the change. You don't get much in the way of specifics. The next level down is really this sort of more species turnover, species distribution models, ensembles of species distribution models, where you get a bit of a sense for what are the particular things and how are they actually changing. And that's a little bit, doesn't cast quite as broad a picture, but it's a slightly brighter light. And then when you get down to species and population levels, people have actually coupled species distribution models, population type parameters into specific interactions, and that gives you a really pointy picture, but just for a narrow part of biodiversity. So what we did was we actually looked across all of that work. There's coarse filter approaches, like, I'll skip over these. These are just excerpts from some of the work that we've reviewed. This is out of the last IPCC report. There's one that Dan drove before, similar sort of coarse climate velocity type exercise. There's people who've looked at species type turnover. Again, some of the stuff Dan was talking about was done in the basins, been done nationally. And there's also individual species-based work where they've looked at models of species change, taking into account population parameters and other things on top of climate change. This is just an example for the pygmy blue-tongued lizard. So you bring all that together and go, well, there's still a huge amount of information out there. How much of it can we actually use? And so what we've actually gone through is, it's all peer-reviewed, so it's all quality information, but how much of it is actually fit for our purpose of trying to make management decisions? So we actually used a bit of an uncertainty cascades approach to go, how much uncertainty can we tolerate within the work that's been done before our management decisions would change? So how much of this can we actually take into account? And the process we used was to go, look, was the conceptual approach valid? Was the right data used? Were the analytical techniques appropriate? And was the interpretation able to be something that we can actually pick up and apply for management? So what you find with this is if you've got a certain amount of uncertainty at that bottom level, it increases the uncertainty every step up that sort of cascade. So what you find is if you have a fair bit of uncertainty at that sort of basic level, it'll cascade into some very significant level of uncertainty compared to the management decisions you have to make. So what we ended up doing was going, look, if there's a fair amount of uncertainty in any of these fundamental levels of analysis, then we probably can't use it to guide management. It's only those elements that make it right up to the top there that are worth using. And when we look at the sort of coverage across those different facets of the biological hierarchy, from landscapes through to ecosystems down through to species and populations, we find we've got pretty good coverage at that really coarse level. We've got partial coverage when you start getting into that sort of ecosystem species turnover type level, and we've only got very minor coverage across the issues in our region when you start looking at sort of population demographics, those sorts of issues. So we tried to bring that evidence together into a bit of a framework to go, look, we've got fundamental drivers, we've got those inherent system properties and how they'll respond, so inherent levels of exposure, sensitivity, adaptive capacity. There's also, as Dan was saying, the realised exposure, sensitivity and adaptive capacity, where you look at what are the current impacts, what are the threats, what's the dynamics of those systems as a result of all the existing changes. So you combine those with the nature of system response, and you can find that in some cases we have almost a buffering effect, where the way the system responds to climate change tends to dampen the impact of climate change. You can have a reinforcing effect, and you can have an amplifying effect. So, for example, climate change in a soft coastal sedimentary systems with development that impedes coastal migration, the effect of climate change is actually exacerbated in those sort of scenarios. So then what we've done is looked at that and how does that relate to our values and goals, and what does that mean in terms of our response. Another framework element we've looked at is we've tried to use a sort of a common conservation planning approach, looking at the nestedness of our different conservation assets. So in some cases you find that you've got species nested within ecosystems which are nested within landscapes, and they've got common needs. So you can focus on one level of the biological hierarchy, pick up those other things. Of course, that's not always the case. We've got certain ecosystems that might not actually, they might have unique needs that aren't represented by the broader landscape, and they have species within those, and sometimes you've got species that have unique needs that will not be picked up by those other levels. So you kind of work out what elements do you need to focus on across the biological hierarchy. And just another little bit of context is the strategies you can apply, and this is similar to the information Dan was presenting before. At one end, you can be looking at really just increasing the resilience, doing the things we're already doing to conserve biodiversity and helping it to adapt. At the other end, we might be facing transformational change, where what we've been doing now in no way can help to address climate change adaptation. A good example being that sort of coastal squeeze, where you've got sea level rise, human development, there's nowhere for those systems to actually migrate to, and so they basically get squeezed out of existence, that sort of that transformational space. So in terms of our region, if you imagine the Mount Lofties as the sort of high rainfall spine of the range, the sort of rolling hills country, the plains and the coast, those are the sort of four broad landscape elements. On top of that, there are two obvious ecosystem types that are particularly vulnerable, that don't necessarily reflect those broader categories. So you've got coastal systems, or soft coastal systems I should say, and water-dependent ecosystems. So we've gone through all of those. We've looked at their inherent system properties, and sorry I'm racing through this, I won't go into the detail. There's a lot of information that sits in every one of these little boxes here. But we've gone through inherent system properties. We've looked at the realised system properties, where you take into account how they've been modified already. And then we've gone into what are the scenarios we're facing, the various emission scenarios from 2.6, 4.5, 6.5, 8.5, and looked at the adaptation capacity based upon those different scenarios. And what pops out at the end is we've got some particularly vulnerable areas. So those sedimentary coastal systems, really looking at transformational scenarios where they're getting squeezed out of existence by sea level rise and impaired migration due to existing development footprint. The water-dependent ecosystems, again, small changes in rainfall have dramatic effects in terms of water availability in those systems and their dynamics. And then we've got this sort of transitional zone between the plains and the hills, which is where a sort of grassy woodland belt is. And that area also shows that it's inherently sensitive to some of these changes, and is actually starting to, when you look at, this is just a sort of a climatic envelope, just picking up on a couple of climatic variables, but you can actually see these are the different scenarios. This is 8.5 here, but this is the envelope for just, the dots here are selected climatic sites across South Australia. This is just the broader envelope. This is that woodland belt, and under the lowest scenarios, we'd actually see probably a fair bit of reassembly but within the sort of climatic range that some of these systems experience. By the time you get to 8.5, you're starting to step right outside of that. So you're talking about pretty fundamental reassembly of these ecological communities, and the nearest analogues we were able to find are actually in the sort of western slopes of New South Wales. So in some ways it's a slightly not quite as catastrophic as we were thinking. You know, it's not turning necessarily to mallee type systems or those sorts of things, and there are some common species in there, but we are talking about some fundamental reassembly outside the realms of what our current systems experience. So same picture Dan had there. We've got transformation. We're facing some of those coastal zones. We've got areas where we want to increase resilience, but under the worst case scenarios we're actually looking at probably active adaptation. We've got some areas where we'd be looking at active adaptation but potentially transformation, and we've also got some areas there where hopefully we might be able to get away with just improving their existing resilience by reinstating processes, taking out threats, but under a worse scenario we might be actually having to look at some more severe interventions. And what we're also trying to do is, that's at a very coarse scale of landscapes, broad categories. We're actually trying to look at individual landscapes, how they've been modified, what are the values left in them now, and what does that mean. So for example, we've classified all the landscape types across the region based on their sort of, what we believe their historic biological components would be from their environmental drivers. We've looked at what their future, or what their current modified patterns are, and we're actually finding that we've got some areas where, say, this for example is that sort of heathy forest country, where that's been converted into sort of open pasture, open woodland country. There's a high contrast between what it was historically and what it is now, and we've actually lost, and you can measure that loss of a whole heap of species out of those systems. In the other areas, say on the eastern hills, we had sort of open woodland type systems, and they're still open woodland systems, albeit modified for grazing and livestock. We've actually got a lot of those components still hanging on, the biological components still hanging on those systems. So we actually look at it in terms of where are we on this trajectory of change already, and then bring that information into the climate change mix to go, what will be the implication in terms of further losses under climate change scenarios. And we're still in the process of doing that right now. So it's that downscaling exercise, getting down to individual landscape units. In terms of where to from here, what we really need to do is start to broaden the debate with the community around what are the values that people have around conservation issues and environment, and what are the implications under climate change. Start actually implementing some of the things we've learned already, but also fill policy gaps. In terms of implementation, there's both the policy side, reflecting this in legislation and how we actually make decisions through land use planning, some of those things, and also on-ground delivery. We also need to fill some of these critical knowledge gaps we're finding and monitor and track certain elements of the biota so that we can actually tell whether the expected changes are what we're seeing, because there's a lot of uncertainty in this space, and set some triggers with the community around when we're looking at potentially challenging adaptation options. We're talking about things such as coastal migration or some of those very challenging issues where what we're doing now in no way reflects some of the issues we're probably going to have to tackle in the future. And that's it. Thank you.
Thank you, Andrew. Have we got any questions for Andrew? Ooh, you can ask him when you present, Doug. So how about the front here?
Yeah, it might relate to the other speakers as well. Adaptability, vulnerability, adaptive capacity.